Okay, well, it is 6:30, so we will begin. Hello, everyone. Happy 2025. My name is Lori Bishop. I'm a nutrition advisor with Brooks Equine Nutrition. Welcome to our first educational webinar series on various nutrition topics, and thank you for taking the time out of your busy schedules to attend. We hope to continue this series with more topics people would like to learn about. And I'm so happy to see such an amazing response. Like, we've really had a great response for this. Before I introduce our special speaker, if you have any questions, please place them in the Q&A box. You should be able to find that along the top. I will be monitoring everyone's questions, so I will have lots of time at the end for questions and answers. I might interrupt if a really good question comes up. And you're okay with that, Dr. Young?
Oh, yes.
Okay. We probably will send out a survey at the end of this just to see if we can make any improvements or what topics people might like to have included going forward. So let's get started. I am so happy to introduce our special speaker, Dr. Katie Young from Kentucky Equine Research. I'm going to turn it over to Dr. Young so she can share a bit about herself, and we'll get started with the webinar. Dr. Young, go ahead.
Well, thank you, Lori. And this is me. This is just kind of a little synopsis of my history. My history as an equine nutritionist and a little bit of my background in horses. I got my undergraduate degree at Missouri State University, and I actually taught some of the undergraduate horse classes while I was there. And I got my bachelor's in biology and minored in animal science and chemistry, and then started working on a master's degree in immunology. And then my ex-husband decided he wanted a PhD in analytical chemistry, and I said, well, if we're going to do that, then I want a PhD in horses. So we went to Texas A&M, and I ended up with earning a PhD in equine nutrition and exercise physiology. And then I stayed there for a few years on the faculty in the horse section, teaching horse classes. And then it was time to go, and get a job that, as my major professor said, kind of in the real world. So I ended up as equine nutritionist and horse feed program manager at Farmland Industries. That company actually is now bankrupt. And after that, I went on my own as an independent nutritionist and contracted with Purina. And after years of doing contract work for Purina, they hired me. So I spent about 20 years with Purina, and much of that time I was the technical equine nutritionist in charge of the horse feeds. So those of you in the US, a lot of the horse feeds that you might recognize, I was the formulating nutritionist behind that. And then we parted ways several years ago, and I went back into independent consulting, but I've known Dr. Joe Pagan, who is the owner and founder of Kentucky Equine Research, for more years than I care to specify. And we talked, and it was a really good fit. And so I'm now a consulting equine nutritionist with KER. And I also do independent consults with veterinarians and horse owners and around the country. So that is my nutrition background. As far as horses, I started out barrel racing as a kid, and when I was 18, and I don't want to insult any 18-year-olds, but those of you who are older than 18, when I was 18 and of course knew everything that there was to know about riding Western, decided to try something new and went into the hunter jumper world, where I rode hunter jumper equitation for, a couple decades, and then started getting older and bad knees and a bad back, and so made the logical progression into eventing. So that's where I've spent the last quite a few years, and the pictures on here are horses that have been mine. I always like to point out the guy in the middle there jumping. He just passed away last year at the age of 37 and a half, flaming PPID, and the picture just below that was taken shortly before he passed as he was still doing riding lessons. And sweet old man gave a lesson the day before he went to sleep in the pasture with his friends and did not wake up the next morning. So that was Boo. I will refer to Boo in many presentations. I refer to Boo because he was my test subject for so many things in equine nutrition. But anyhow, the other picture in there, as I'm standing with a Clydesdale, one of the fun things I've done in my career was the nutritionist for the Budweiser Clydesdales for about 7 years. So that was very fun, and again, learned a lot of things about dealing with the big horses. So that is me. Now let's move on in and talk about forages, because that's what you really want to learn about tonight, hopefully, if you're on this webinar. And why the big concern about forages? Well, forage is the base of all equine diets. There is an absolute need for forages in the horse's diet, an adequate amount of forages to maintain, number one, nutrient requirements. There are a lot of nutrients that are well supplied by forages, not all of them, but many of them. A lot of calories from forages, and forages, the fiber in forages is essential to help keep the horse's gut healthy. In general, we recommend at least 1% of the horse's body weight is on a dry matter basis of forages. So if we're talking about hay, which is already pretty much dry matter, a 1,000-pound horse, 1,100-pound horse needs a minimum of 10 to 11 pounds of hay per day to keep that gut healthy. Now that's the minimum. Of course you can feed more than that, and usually in reality we recommend 1.2 to 2% of their body weight. So a 1,000-pound horse, that's going to be about anywhere from 12 to 20 pounds of hay per day. Some horses will eat more than that. I've seen horses that will consume 3% per day of their body weight. And for some horses, that meets their calorie requirements quite well, but we're going to talk about, does it meet all of the nutrient requirements? We're going to talk about, do forages meet the fuel source requirements for different types of exercise? And then what about quality of forage? Because the quality of forage is a big concern with how well does that forage meet any nutrient requirements. And then we're also going to talk about a forage analysis. Is it necessary? Is it recommended? And if you do have a forage analysis, then what do you do with that? How do you interpret the forage analysis? Now, I've been in the feed industry since I left Texas A&M, and so much of my life has been recommending appropriate feeds and selling feeds for horses. But one of the feedback I get very often is, well, horses live naturally on pasture. Do they really need anything besides pasture? Well, we'll talk about that. One of the things at first I'll bring up is, okay, horses live naturally on pasture. What sort of pasture? Because the slide I just showed, which had a really nice green pasture, okay, is that natural pasture? And the picture here on the right, you see a whole lot of pastures like that, even these days. And then you think about, okay, wild horses that are surviving on pasture. What kind of pasture is that? Sometimes like this, maybe. How often do horses actually live on nice, lush green pastures? And certainly, if you think about 12 months a year, not so much. And then the horses that live naturally on pasture, what are they doing? Are these horses in this slide living naturally on pasture? Probably not so much. And when you think about what Mother Nature intended for horses, even back when I was a kid, what was the length of the lifespan for a horse? Because when I was a kid, a 20-year-old horse was considered a senior. That was an old horse. And now here we had Boo, 37 and a half, still giving riding lessons, walk, trot, canter, and jumping. So that's not so much what Mother Nature intended. And horses' lifestyles today with performance, with we want to maximize, if you're breeding horses, we want to maximize healthy growth. We possibly want to maximize the size, how big our horses get. Is that what Mother Nature intended? Not so much. And then I talk to people and they say, well, my horse is fat and shiny on pasture or even hay alone. Why do I need anything more than that? Well, think about that. Fat and shiny, is that the same as healthy? Because personally, and I'm a nutritionist and I know better, I could stay fat and shiny on a diet of Oreos, or actually Girl Scout Thin Mint cookies. That would be a lovely diet. I would be so happy. Would I be healthy? Probably not so much. So going on from that, also have to keep in mind that pasture and hay is not the same nutrition. Pasture is magic. Green grass is magic. But as soon as you cut that grass, it starts losing nutrients. So for the most part, I am going to talk this evening about hay. Some of the things I'll talk about also apply to pasture, but again, there are a lot of nutrients in pasture that once the plant is no longer growing, those nutrients deteriorate. So for calorie requirements, I want you to just think about how well does forage meet a horse's nutrient requirements? And we're just going to go through a few of the nutrients right now. For an 1,100-pound horse in intense work, the energy requirement or calorie requirement is 34.48 megacalories a day. If you are trying to meet the calorie requirements just with hay, alfalfa hay is approximately 1,000 kilocalories per pound. Grass hay is approximately 800 kilocalories per pound. That's on average. So to meet the calorie requirements of an intensely exercising horse, you would need 34.5 pounds of alfalfa a day. That's a lot of alfalfa. And you'd need 43.1 pounds of grass hay per day. So think about that. Your horse would need to be eating a bale of grass hay a day. That's a lot of hay. So for hardworking horses, hay alone's probably not going to do a great job on meeting calorie requirements. If you've got an easy keeping maintenance horse, you most likely can meet all the calorie requirements just with either alfalfa or grass hay. But what about some of the other nutrients, such as copper? Copper is an essential mineral. And now we've got an 1,100-pound horse, and I put him at maintenance or light work. So this is a horse that's not doing a whole lot for a living. And their minimum requirement is 100 milligrams of copper per day. Grass or alfalfa hay average about 8 to 9 parts per million copper. I got to say, I have seen a lot of forage analyses that the copper may be 2 to 5 parts per million. I mean, just really down low. In that case, to meet the minimum copper requirement for a horse that's not even really working much, you got to have 25 pounds of hay per day, assuming that it's 9 parts per million copper. If you get down to 6 parts per million copper, that again, 37 pounds of hay per day. Again, another bale of hay a day to meet just minimum copper requirements. And this is one that always really interests me is zinc. Because a lot of times people don't really think about zinc. It's an essential mineral. It's got a big role to play in things like hoof development, and it's throughout the body. But the minimum requirement here for that same 1,100-pound horse at light work is 400 milligrams of zinc per day. Grass hay averages 25 parts per million zinc. So again, to meet minimum zinc requirement, we're at 36 pounds of grass hay a day. And again, I have seen a lot of hays, that's the average, 25 parts per million zinc. I have seen some that are down in the teens. So you're talking about a lot of hay to just meet minimum requirements for a horse that's really not doing much for a living. And then we start looking at amino acids, and I will talk more about amino acids a little bit later. But in this case, lysine is the first limiting amino acid provided by protein in the diet. And the minimum requirement for a working horse is 43 grams per day. So alfalfa is about 0.79% lysine, and an average Bermuda grass hay is about 0.28% lysine. To meet minimum lysine requirements, we got 12 pounds of alfalfa hay per day or 34 pounds of Bermuda grass hay per day. And I probably should have thrown in some information here on growing horses, because growing horses and lactating mares have even higher lysine requirements. So trying to meet a growing horse's lysine requirements with hay is very, very difficult, if not impossible to do. And I will talk more about the digestion and absorption of amino acids, because I would say these numbers, the 12 pounds of alfalfa and 34 pounds of Bermuda grass hay per day, that actually may be greatly overestimating how much hay it would take to meet amino acid requirements. And then the last little thing to think about is does hay or even fresh forage, does that actually meet requirements of different types of fuel? Because different types of exercise use different fuel sources in the body. And so fermentation of fiber, which is where the calories come from forages, the fiber in forages are fermented in the hindgut, and that fermentation produces volatile fatty acids, including acetate, propionate, and butyrate. Now, for exercise for hardworking horses, they use glucose. Glucose is used to make glycogen, which is a fuel stored in the liver and in the muscle cells. And so when the horse exercises, they break down glycogen. The volatile fatty acids can be reformed into glucose through gluconeogenesis in the liver, but the only volatile fatty acid is propionate that actually can form glucose, and that's a very slow process. So if you've got a performing horse and you're working him hard and you're relying on the forage to provide the fuel for that hard work, it's really not sufficient to refill the glycogen stores in your horse's muscle and liver, because gluconeogenesis is a very slow process. And so horses that are working hard actually need glucose from the non-structural carbohydrates in the diet, which is starch and sugar. And they don't usually get a whole lot of starch and sugar from the forages. Sometimes green grass can be pretty high in starch and sugar, but not compared to some of the feeds that we provide to hardworking horses that need the glucose to refill their glycogen stores when they're working hard. So with all that saying, okay, there's a lot of things to think about in your forage and what your horse may or may not be getting from forage. What do you do? The first thing I want to talk about is the quality of the hay, because the higher the quality of the hay that you feed to the horse, the higher the nutrient content, and also the higher the digestibility, which is the availability of nutrients. So if you're feeding higher quality hay, your horse will get more nutrients from it, even though some of the nutrients may still be a little bit iffy. And we'll talk how to supplement to make sure that your horse is getting all the nutrients. But keep in mind, the better the quality hay, the more your horse will get from it. I'm going to throw in one caveat here, because if you've got really easy keepers that tend to get obese easily, you still need to think about the quality of hay, but maybe you don't want the highest quality of hay. Maybe you want medium quality of hay so they don't get too many calories, and then you're dealing with an obese horse and possibly a metabolic and or laminitic horse, because we certainly don't want that. And I assume everybody on here is a horse person, because if you're not, you're probably really bored by now. But as horse people, a lot of times we figure we do know something about how to determine the quality of your hay. But this is a little kind of quiz I put together because a lot of times we kind of miss what we should be looking at that helps determine the quality of the hay. So, what is the most important factor influencing the quality of hay? And if you were in front of me, I'd be having people raise your hands when you think that, well, this is the most important quality. So you're going to have to be doing this by yourself in front of your computer or phone. But here are the factors. Is it fertilization? Is that the most important factor influencing the quality of hay? You know, if you get hay that's out of a fertilized field versus hay that has just not been fertilized. Or is it climate conditions? You know, how much rain did we have? How hot was it? Just what was going on in the environment while the hay was growing? What about the age of the hay, the time since cutting? Is your hay 3 months old, 6 months old, 2 years old? Is that the most important factor? Or storage conditions? You know, I actually live in Kansas, and we feed a lot of round bales, and the round bales sit outside all year for the most part. So is that the most important factor in the quality of hay? What about plant species? Alfalfa, timothy, coastal Bermuda grass? There are a lot of different species, and is that the most important factor as far as quality of hay? Finally, is the answer none of the above? Well, yeah, that was the answer, none of the above, because by far the most important factor influencing the quality of hay is the maturity at time of harvest. How mature was that plant when it was cut? Because in general, the less mature the plant was, the higher quality the hay is, the more nutrient dense it is, and the more digestible it is. And people don't really think about that. As a matter of fact, the gentleman who cuts the hay out where I've got my horses, we're lucky enough that the owner of the facility has 100 acre of brome that gets cut for our hay. And I was talking just about a year ago to the gentleman who comes and cuts and bales the hay, and he thought once the hay was fully grown, then it was the nutrient content was set. So once it was mature, once it was fully grown, didn't matter if he cut the hay in June or July or August. I was going, oh, yes, 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 it does. It makes a big difference. This is an old slide. This is really old research that just has the yellow line is alfalfa crude protein, the blue is brome crude protein. The red line is alfalfa digestible energy, or basically calories, and the green line is brome digestible energy. And you can see on this, going from June 4th, June 20th, June 30th, July 6th, just that amount of time of maturity. Look at how the crude protein and the digestible energy dropped. That's just a huge difference. And this is more recent research, and this is alfalfa and orchard grass that measured the percent digestibility, and going from June 3rd, June 13th to June 23rd, look at the drop in digestibility. So yes, maturity at time of harvest. People will ask me, do you like first cutting, second cutting, third cutting? And yeah, there are going to be some differences in like weed content and such, but I'm much more interested in how mature the plant was when it was cut. But going through this, I want to talk about all the factors because they do have an effect, just not as much effect as the maturity. And again, the more mature plants are less digestible. The reason being there is more indigestible fiber. The taller the plant gets, the more mature it gets. If you think about the cell walls where the fiber is basically contained, as a plant gets taller, it has to stand up and it has to get more woody, I guess, as a way to describe that. And that is indigestible fiber that gives it its structure. So the older it is, the more indigestible fiber is in the cell wall. I'll talk about that in a couple minutes. Plant species, grass versus legume, yeah, there is a difference there. The legumes tend to be higher in crude protein, tend to be higher in calcium, tend to be higher in digestible energy. But if you take a very high quality grass hay versus a moderate to poor quality legume, the grass hay may actually yield more nutrients than the legume. So again, it just kind of depends on that individual hay. Fertilization primarily affects the yield at a given maturity. So basically bales are pounds of hay per acre. If you fertilize, you're going to get more hay per acre. Does that affect the nutrition? Sometimes yes, sometimes no, because if you've got soil that is lacking in nutrients and you provide those nutrients in the soil, that can help with the hay's actual nutrient content. Climate conditions, the excessive moisture or drought can affect the lignin content, and the lignin is that indigestible fiber. So if you've got extreme conditions, that certainly can affect the nutrient content and digestibility. Again, not as much as maturity at time of harvest. And then the age, the time since cutting, and storage conditions, that does affect, but primarily that affects the vitamin content. Because when green grass is cut, green grass is a great source of vitamins, particularly vitamins A and E. And once it's cut, it starts losing that vitamin activity. I'll talk a little bit more about that in a few minutes. But in general, hay that is 3 to 6 months old, I quit giving much credit to vitamin A or vitamin E in that hay. And hay that's a year old, that horse is not getting vitamin A or vitamin E from that hay. So what do you look for when you're trying to evaluate the hay? What are the characteristics of good quality hay? Because it's all well and good to say maturity at time of harvest, but how do you tell that? Well, the things you've been taught and you've heard about how to evaluate hay, most of those things actually have to do with maturity at time of harvest. The high leaf to stem ratio. The older the plant is, the fewer leaves and the more stems. Even with grasses, the grass hays, even coastal Bermuda grass, the more immature the grass is, even though those blades of hay are just tiny, tiny, you can, when you have them sitting side by side, you can tell the younger plant has a little bit broader blade. Small diameter stems, again, as a plant gets older, it gets more stemmy. Few seed heads or blooms. In general, for grass hays, we would like it to be for optimal nutrition. You really want it cut before there are many seed heads. And I always get tickled with Timothy that I'm the same way as everybody. I recognize Timothy from that really specific seed head. But if you see a lot of those seed heads, then that's pretty mature grass. And in alfalfa, we usually want that cut at like early bloom. So, well, alfalfa may be mid-bloom, but it's good to see some blooms. And a lot of times you don't see many blooms in alfalfa, but those are the things we look for. The fresh smell and appearance, that's more to give you an idea of the age of the hay and the storage conditions, because you do want it smelling fresh. You don't want it musty smelling. You certainly don't want mold. You'd like to see it nice and green. The cleanliness, free from mold, free from dirt, free from trash, all those things that we don't want in the hay for horses. The color, a lot of times if the hay sits outside, it's going to oxidize a little bit on the outside. So you really want to look at the inside of the bale of hay, because if it's still nice and green and fresh, then that hay is probably just fine to feed, even if it's a little bit yellow on the outside. And one of the big things I look for, it should feel pliable and soft. When you take a handful of the hay, you want it really soft and squishy in your hand. If it's very prickly and feels like it's a bunch of sticks, well, that's overly mature hay, and the horse is not going to want to eat as much of it. It's going to be uncomfortable for the horse to eat, and it also is not going to be as quality as far as digestibility and nutrient content. So having said all that, what about a forage analysis? Do we all need to be running forage analyses on our hay before we feed them to our horses? I got to say, I don't in my horses. But the times that I recommend a forage analysis is when you really need to know what the nutrient content of your hay is. Is there a medical reason that specific nutrients are of concern? And that may be various nutrients. Sometimes HYPP horses, that may be the potassium you're worried about. Horses that are insulin dysregulated, you might be looking at sugar and starch content of the hay. It just depends, but if there's a medical reason and that horse is very, very sensitive, it may be worth getting the hay analyzed before you choose the hay for your horse. Is the quality of hay a concern for the class of horse? If you're growing a lot of babies, then maybe you want to make sure that your hay is of good quality, and maybe you want to go to the point beyond what you can get just from a visual appraisal of the hay. And finally, is the hay purchased in large batches? Because realistically, you've got to think about, okay, as I'm selecting hay for my horses, how much hay do I buy at a time? Because one of my guys now who is 24, I'm buying alfalfa for him because his dental condition is such that he's not chewing the grass hay available nearly as well, but he can still chew alfalfa just fine. Now, am I really concerned about the alfalfa? And I'm getting a few bales at a time. So as far beyond the visual appraisal, I'm not really worried about the nutrition of this particular alfalfa. And since I buy in a few bales at a time, by the time I got a forage analysis back from those bales, I'd be on to the next bales. So in my situation, no, it's really not a big deal. But again, if your horse has a medical issue, then it might be a very big deal. If you're purchasing hay in large batches, so it's feasible, then shoot, yeah, it's really pretty cost effective to get some nutrient information from analysis. But if you do, then what do you do with the results? Because when you get a forage analysis, there's a lot of information on there, and how are you going to interpret that? So we are now going to go through how do you deal with a forage analysis. Most forage analyses that you get back, you are going to get these nutrients. You're going to get crude protein. You're going to get carbohydrates, depending on where you have the analysis done and what analysis you ask for. There are a bunch of carbohydrates that you can get. First, you can get the structural carbohydrates, or the fibers. And in general, you're going to get crude fiber, ADF, NDF. And then if you ask for it, you will also get the non-structural carbohydrates. And the assays, the analyses for non-structural carbohydrates include non-fiber carbs, non-structural carbs, water-soluble carbs, ethanol-soluble carbs, and starch. I will go through those and we will talk more in depth about them, because people get really hung up on the non-structural carbs in forages pretty often. You're going to get some minerals. You're likely not going to get vitamins on a typical forage analysis. And you're also going to get, and this is something that a lot of horse owners don't even look at and don't know how to interpret, relative feed value. And I personally use relative feed value quite a lot. So now let's go through each of these. Crude protein. The analysis for crude protein is actually just a measurement of the nitrogen in the sample that's sent in. So it tells you that it's a calculation of the total amount of protein, but it doesn't actually tell you anything about the protein quality, which is the amino acid profile in that forage sample. It doesn't tell you anything about the site of digestion where the protein is digested and absorbed from that hay that they're eating. And it doesn't say anything about how available the individual amino acids are. So I'm now going to take you down a rabbit hole of protein in horses. Because to really understand this, you've got to understand equine digestive physiology. And I'm sure none of you thought when you signed up for this webinar that you were going to learn about equine digestive physiology. But sorry, I'm a nutritionist. I find this fascinating. And I also think it's really important to understand the digestive physiology when you're making decisions on what to choose to feed your horse. So you may not recognize that this diagram is a horse from the viewpoint of the digestive system of the horse, because if you see on the left side of the diagram is a dog, and on the right side is a cow. So we actually have the horse is basically a dog cow when you think about its digestive system, because the front part of the horse's digestive system is really similar to a dog's, as the horse is a monogastric. But the back part of the horse's digestive system is more similar to the front part of a cow's digestive system. And here is a little diagram from the same source that has the cow, the horse, and the dog digestive system. So let's just quickly compare these. The cow's stomach. Now, and Lori, you tell me, can you see my my cursor here as I'm circling on the cow's stomach? Nope.
Yeah, I can see it.
Oh, you can. Okay, great. So this is the cow's stomach. Look how big that is. And the reason it is so big is because the cow's stomach is actually 4 compartments. They are called ruminants. The biggest compartment of the cow's stomach is the rumen. And if I had a wheelbarrow in front of me, the cow's rumen would pretty much fill up that wheelbarrow. It is a great big old bag. And it's full of bugs, bacteria, and protozoa. So when you feed a cow, everything you feed gets dumped into this huge microbial vat. And the microbes, the bacteria and protozoa, actually ferment the food that you feed the cow. So in the horse, you see the horse's stomach is small relative to the cow's, as is the dog's. So in the horse and the dog, we have monogastrics. So these are simple stomachs, which is actually the same type of stomach that we have as humans. It's a small bag. It is not a big microbial vat. Instead of the bacteria and protozoa, we have hydrochloric acid and some enzymes. And so that's what, when we eat, the horse eats and the dog eats, in the stomach, you have the acid and the enzymes that start digestion. And then moving on, I'm back to the cow. Coming out of the cow, you see all this long, skinny line, that's the small intestine. And you see in the horse, small intestine looks pretty similar. And the dog, small intestine looks pretty similar. And it is true, small intestine in the cow, the dog, and the horse are all very similar. What happens in the small intestine, the digesta that comes out of the stomach moves through the small intestine, and there are many more digestive enzymes that are either produced in the small intestine or like dumped in from the pancreas. And so in the small intestine, there's a huge amount of digestion of nutrients, and this is a big deal. The small intestine is the major site of nutrient absorption. So much of the nutrients that the animals get from whatever they're fed, much of the nutrients are absorbed in that small intestine. Okay, so after the small intestine, we get into the hindgut. And the first part of the hindgut, you can see in the cow is the cecum. And in the horse, this is the cecum, great big bag. And in the dog, this is the cecum. And in people, we have a cecum similar to a dog, but it's called an appendix. And, they take out our appendix and we don't even care. But in a horse, this cecum is a huge vat, holds about 18 gallons, and it is full of bacteria and protozoa. So anything that gets through the small intestine and gets into the horse's cecum is then fermented by the microbes in the cecum. What does that sound like? Does that kind of sound like a rumen in a cow? Because it functions very much like a rumen in a cow. So the digesta that makes it through the small intestine into the cecum is then fermented. And then there are more protozoa. You can see from the cecum, I gotta find there's my cursor again, into the rest of the large intestine. You can see how that's just kind of a foldy, big, wide tube, and there are many more bacteria and protozoa that are continuing the fermentation through the rest of the horse's hindgut. We call horses hindgut fermenters because the fermentation takes place in the hindgut. True monogastrics like dogs and people, we have very little fermentation in the hindgut. Why is that important? Because let's look at what happens in the sites of digestion in the horse. We have the upper gut and we have the hindgut. So in the upper gut, we have enzymes and hydrochloric acid. The enzymes are throughout the upper gut, hydrochloric acid pretty much just in the stomach. And so with enzymatic digestion, fats in the diet are nearly 100% digested and absorbed in the small intestine. Carbohydrates, the starches and sugars, are primarily digested and absorbed as sugars, and glucose is the main sugar in the small intestine. But in the small intestine, there is no fiber digestion, because even though fibers are carbohydrates and are made up of sugars, very similar to starch, they don't look anything like starch because the bond that holds the sugars together is a different sort of bond, different chemical bond, and no mammals make the enzyme to break that bond. Microbes are needed to provide the enzyme to break fiber bonds. So there is really very little fermentation. There's a few microbes in the upper gut, but not many. So there's not a lot of fermentation of starch or sugar in the upper gut. It's enzymatic and you get glucose and simple sugars. And then those nutrients are absorbed from the small intestine into the bloodstream. Protein in the small intestine, protein digestion breaks proteins down into its individual amino acids. And the amino acids are absorbed intact from the small intestine. And that is a really important thing when you're working on meeting your horse's amino acid or protein requirement. Now in the hindgut, where we have the microbial fermentation, the carbohydrates that make it into the hindgut, which is primarily the fibers are then digested or fermented by microbes, and the fermentation product are those volatile fatty acids. Remember, I talked about those as far as meeting the horse's energy requirements versus fuel requirements. The VFAs are a pretty good deal to meet a maintenance horse's calorie requirements, but not so good to refill the glycogen stores, that fuel that's stored in the liver and the muscle fibers. Now, the thing though with carbohydrates, we all know that the starches and sugars, like from a big meal of grain, can be a problem. If the horse suddenly eats, they get into the feed room. It's a whole bag of grain that is high in starch and sugar. For instance, something that is primarily one of the cereal grains like corn or oats. Then you can get so many starches and sugars in a meal that it overwhelms the capacity of the small intestine and it overflows into the hindgut. And then the microbes in the hindgut are going, yay, we've got a bunch of starch and sugar that we're not used to, and you get all this fermentation of starch and sugar, and it can lead to colic and or laminitis. It can be a really bad deal. One of the reasons that we always say make changes gradually when you're making feeding changes to the horse is so you don't get a sudden overload of soluble carbs into the hindgut, causing problems with the microbes. But then back to protein, because we are still in the category of protein at the moment. The thing with protein in the hindgut, because they're always, especially from forages, you're going to get protein from the forages in the hindgut. And in the hindgut, the microbes do not break protein into amino acids. They tear the protein apart. And so instead of getting amino acids, you get nitrogen and a little carbon skeleton. And the carbon skeleton can be used for energy, but you're not going to get amino acids absorbed in the hindgut. And the trick is, horses don't have protein requirements, they have amino acid requirements. And there are some essential amino acids that they have to get from their diet because their body cannot synthesize those specific amino acids. And the relative role of the small intestine in the digestion and absorption of protein is limited even with top quality forage. And many people don't realize this. They just assume that all the protein in the forage is working to meet the horse's amino acid requirements. But in one study, they looked at true digestibility of nitrogen in high quality alfalfa. And in the upper tract, only 37% of the protein from that alfalfa was digested in the small intestine. Although if you looked at the digestion in the total tract, it was 74%. And then in another study, this was conducted at Texas A&M, Pete Gibbs, who's a friend of mine, looked at Bermuda grass hay and kind of low moderate protein alfalfa, and then a little higher quality alfalfa. And in the average quality alfalfa, which was 15% crude protein, only 2% of that protein was digested in the upper gut, which means 98% of that protein was not useful for meeting a horse's amino acid requirements. So I've got people who say, well, I'm feeding alfalfa, I don't have to think about protein. And I'm going, yep, you still might need to think about protein. So it's easy to overestimate the contribution of amino acids from hay in a horse's diet. And quite honestly, with other nutrients, we have some of the same concerns because some of the minerals in particular are only absorbed in the hindgut. So, and some of the minerals are only absorbed in the upper gut. So if they're not available in the upper gut because they're maybe inside the cell wall of the plant, is the horse actually getting them? And again, horses don't have a protein requirement, they have amino acid requirements. So kind of summary, protein digestion in the upper gut yields amino acids, protein digestion in the hindgut yields nitrogen and a carbon skeleton and no amino acids. And the amount of protein digested in the upper gut is influenced by the amount of fiber in the hay. And what determines the amount of fiber in the hay? Maturity at time of harvest. See, it all wraps up. It's all related. So Lori, are there any protein questions that I should address before I go on to carbs?
I just have one question that's about preservatives, so we can leave that one till later.
Okay. Yep, that sounds good. So let's get into carbs because carbs are complicated. You thought protein was complicated. And remember, we're still talking about the analysis. So everything I talked about with protein was just because you're getting crude protein from your forage analysis. The carbs, you're going to get cell wall carbs, which are the fibers, which is crude fiber, neutral detergent fiber, and acid detergent fiber. And then you're also going to get cell contents. Depending on your assay, you could get starch. You're not going to see sugars because sugars are going to be captured by water-soluble carbs, ethanol-soluble carbs. You might see fructans, which is a different type of carb. And then you might see NSC, you might see NFC. So let's get down a little bit more. We'll start with the cell wall. And I have the citation from this cool plant cell diagram that I stole off the internet. But crude fiber, almost every analysis you see is going to have a crude fiber, and actually feed tags also usually have crude fiber, but quite honestly, that value is not much value for non-ruminants. It may be helpful for like cattle, but for horses, we very rarely look much at crude fiber. We look more at NDF and ADF. Neutral detergent fiber and acid detergent fiber. Neutral detergent fiber represents the cell wall components, the structural carbohydrates, which include hemicellulose, cellulose, and lignin. So neutral detergent fiber pretty much has all of the cell wall fibers. Acid detergent fiber is just the carb fraction that includes most of the lignin, and lignin is the completely indigestible. It's not even truly a fiber, but it's included in the fibers, but it is a compound that is completely indigestible. But acid detergent fiber also contains a portion of the cellulose, and cellulose is fermentable. So, and when we get to the hindgut, I'm going to be using digestible and fermentable kind of interchangeably, but it's always fermentation. Okay, it's not digestibility is in the hindgut is fermentation. So NDF and ADF give a rough idea of the digestibility of hay, because the more fiber you have in the hay, the less digestible it is, particularly when you look at acid detergent fiber. As it goes up, the very much less digestible that forage is. So things to keep in mind: as ADF and NDF increase, which is the fiber content, digestibility decreases, as does voluntary intake, because as they go up, that usually means the amount of lignin is also increasing, which is indigestible. And then wrapping back around to maturity at time of cutting, the increased maturity at time of harvest increases the ADF, the lignin, which helps keep the plant standing up. Now, one thing I do think about at very exceptionally low ADFs, for instance, the mid-20s, and you sometimes see that with really, really high quality alfalfa, like dairy quality alfalfa, that may not actually include enough fiber to maintain a healthy hindgut. So just something, I'm not going to say if that's what you have available. If a horse's gut has been gradually accustomed to that kind of low fiber, those microbes are amazing things. If they have a chance to adjust, and the horse has a chance to adjust, they can handle diets that I'm going, oh, that's just not healthy. And the horse will say, well, you're just wrong. And I'll say, well, okay, if you can stay healthy, good for you. Okay, so that is fibers. And now we're going to jump into the cell contents. Because remember, fibers are carbs. It always tickles me. I was editing an article that was going for a magazine, and in that they said for horses that are prone to laminitis, we recommend a low or no carb diet. I'm going, okay, that's impossible. You cannot do that, because fibers are carbs. They're just structural carbs. The carbs that people get all excited and worried about are the non-structural carbs, which are the cell contents. And I'm going to say right up front, yes, there are some horses that are very sensitive to starch and sugar in their diet. And in those situations, we got to be careful about the total amount of soluble carbs. And I use soluble carbs and non-structural carbs fairly interchangeably as I talk about these things. But for a healthy horse with no issues, no sensitivities to soluble carbs, we don't have to get so wildly conservative in trying to limit the soluble carbs in their diet. And I've gone on sometimes I get on my soapbox and say, for some of these horses, please give them an oat. They need an oat. But yes, there are sensitive horses that we need to be aware. And unfortunately, the research on where the the lower levels we need to be on all these different sensitivities, a lot of times we don't have that research yet. So people just keep going lower and lower and lower, but we are actually starting to see some horses that need more soluble carbs in their diets to be healthy and to support, for instance, hard work. But anyhow, back to forage analysis. The things you're going to be looking at when you ask for the soluble carbs or the NSC assays, you're going to get starch, you're going to get water-soluble carbs, which includes the sugars and pretty much all the fructans, which is another soluble carb that tends to be present in some plants not so much. Then ethanol-soluble carbs, which tends to include the sugars, and instead of all the fructans, only the short-chain fructans. And unfortunately, we don't have a really easy, handy-dandy assay to get just sugars. So this is a tricky thing when you're dealing with analyses, is sometimes the chemical assays are not the same as the physiological fractions or the physiological carbs that we need to worry about. So it gets tricky in interpreting these assays, but anyhow. You often will see a non-structural carb or NSC value, which is actually, NSC is kind of defined as starch plus WSC. You also often see an NFC, which is non-fiber carbs, and that is just a calculated estimate of the cell contents. And so that is 100 or 100% of everything in the sample minus the percent crude protein, minus the percent neutral detergent fiber, and NDICP, which is neutral detergent something crude protein. It's another assay you see more in ruminants. And then plus fat and ash. So you put all that 100 minus all this stuff, and that gives you the estimate of cell contents. But in reality, there's experimental error on every one of those assays. So by the time you get to the actual NFC, that number really doesn't mean much of anything. So when you see that, I don't ever even look at it. I look at starch, I look at WSC, and I look at ESC. So ethanol soluble carbs, which remember are the sugars and then the short chain fructans, you take ethanol soluble carbs plus starch, and those analyses are commonly used for feed tags in the US. So when you see a feed that is making claims about carbs anywhere on, on the bag, on the label, and the brochures, then according to regulations, then the maximum starch and the maximum sugars should be guaranteed on those tags. And usually feed companies are using ethanol soluble carbs and starch to make those guarantees. Those may be useful when I'm dealing with a horse that's insulin dysregulated. That's kind of what I'm going to look at, because those are numbers that are going to help me in figuring out how much sugar is going to tend to be absorbed from the small intestine, which would trigger a glucose insulin response in the horse in the blood. And that can be useful in figuring if that's going to precipitate problems like laminitis. Now, water-soluble carbs plus starch most closely replicates the value of total non-structural carbs, and that's the value that's been used in most research, the research that helps give us recommendations for what to feed horses that are insulin dysregulated, what to feed horses that have various muscle myopathies that are sensitive to soluble carbs. So that's what I'm going to look for in those situations. I'm looking at water-soluble carbs and starch. The other thing to realize in these assays, the starch is a pretty stable assay, but ethanol soluble carbs and water soluble carbs, there's variability in those analyses. And you have to be really careful when you start looking at those numbers and making big just big conclusions on what you should or shouldn't be feeding your horse. And this is an example. And this is a real life example from, I was dealing with an obese laminitic pony. That of course it was a kid's pony, and so lots of emotional ties here, but we had this obese laminitic pony. We're trying to figure out what best to feed. So these are 3 brome analyses. These are the real analyses. And in the red numbers are the soluble carb numbers, the starch, WSC, and then I added the ESC plus starch, and then I added WSC plus starch to give the NSC. So you can see in the red, looking at those in the next slide, I think is, that's close up with those numbers. So looking at that, which hay do you think would be better for this laminitic obese pony? So you've got brome 1, brome 2, brome 3. And if you look at ESC plus starch, you got 6.3, 8.4, and 9.9. You know, any reasonable person, you're going to look at that and say brome 1, right? It's the same hay. These are 3 different analyses from the same pile of hay. That's why I have a little wild-faced guy down there. So the moral of this little story is a single analysis may not be accurate and can be highly variable. And be careful not to jump to conclusions based on one analysis. I'm going to go back to this slide real quickly because these 3, one was a hand grab done by the owners of the pony. One was a hand grab that I did that I grabbed from 20 different bales in the pile, and one was actually a probe. Going and same 20 bales, but I probed into the middle of the bale and there was that much variability. So it's important to have the analysis done correctly and interpreted correctly. And finally, in critical situations, multiple analyses may be beneficial. So this is from the Equine Analytical website from several years ago, but they've got really good instructions for how best to take samples. And they say use a hay probe, and you can see the little X where you're supposed to put the hay probe and get into the middle of the bale. And for good sampling, you want to randomly choose 12 to 20 bales and put everything in a plastic bag and send in 3/4 to a pound to get your analysis. So I probably really boggled your brain with all the joys of soluble carbs. I will say, if you've got a horse that is really, really sensitive, get help, reach out for help. There's lots of places you can go to get help. There are, like Kentucky Equine Research has equine nutritionists on staff to help you. Brooks, of course, has the nutrition advisors to help you. You can reach out, you can get help on how to interpret these analyses. But when you really got to make sure that the soluble carbs are low, soaking hay will reduce the soluble carbs in the forage sample. 30 minutes in hot water or 60 minutes in cold water will remove some of the soluble carbs, not all of them, but you don't want to remove all of them. You also have to keep in mind you'll also remove other nutrients, because some of the minerals and some of the soluble proteins you will also remove. If you do need to soak your hay, be sure, soak the hay, pour off the water, and then feed the remaining hay to the horses. I have seen people who just shove that whole muck bucket in, and then the horse eats the hay and drinks the water that has the soluble carbs in it. So really didn't help much. Okay, so moving on from soluble carbs, vitamins. Now I put vitamins in here, but quite honestly, you don't find vitamins on a forage analysis. I would like to, but vitamins are expensive to assay. So unless if you're wanting to spend some considerable amounts of money, you're not going to be paying to assay for vitamin A and vitamin E in your forages. But keep in mind, as I said before, some vitamins, yes, thank you, Livy. There's obviously a murderer out in front of my house, and my dog is taking care of me. But the aged hay is a poor source of vitamin A and E. Vitamin A decreases after the bloom stage, even in a live plant. And so 50% less of maximum carotenoid, which is the precursor of vitamin A that's in the live plant. So 50% less of that carotenoid value is in mature plants versus immature plants. And then both carotene and actual vitamin A are destroyed by oxidation. The process is accelerated at high temperatures, but from some old research, and so this has been known for a long time in forages, much of the carotene content is destroyed during field curing. Greater than 80% of carotene in alfalfa was lost during the first 24 hours of the curing process. And then there was additional loss of approximately 7% per month of storage. So again, after 3 to 6 months, I'm looking at hay saying, don't know that the horse is going to get a huge amount of vitamin A activity there. And same thing with vitamin E. In research, Timothy hay lost as much as 60% of its vitamin E activity when stored in swaths for 4 days. And then in other research, alfalfa stored at 30 degrees centigrade, which is 86 degrees Fahrenheit, for 3 months, lost 54 to 73% of the vitamin E activity. So for those reasons, if your horse, I had a horse that tried to rip his foot off, his hoof off a couple of years ago, and he did not get out on green grass for about a year. So I supplemented with vitamin E, aqueous natural vitamin E, which is the most bioavailable source, just to make sure, because I wasn't counting on him getting any vitamin E from his forage, and I wanted that foot to grow back, so I wanted to make sure he got enough vitamin E, but actually vitamin A as well. Horses that are on forage need to have nutrient supplementation to make sure that they get everything that they need. I will repeat this later, but amino acids, vitamin A, vitamin E, some of the minerals, so at least a vitamin mineral supplement. And I am a big fan of ration balancers because then they're getting protein and very available amino acids as well as the balanced vitamins and minerals. Okay, but minerals, we talked a little bit about some of the specific minerals. Minerals in hay are stable over time. When the hay is cut, the minerals are there, they're not going to go away. Some of the minerals are very expensive to assay, such as selenium. And we do know in North America, there are areas that are very deficient in selenium, and the forages from those areas are going to be low. There's some areas that the selenium is very high. So it's good to know if you are in a high selenium or low selenium area, just to kind of know if your horses are getting where they are on their selenium intake. And as I mentioned before, forages tend to be deficient in some of the other minerals, including zinc and copper, and sometimes even phosphorus. Now, what about magnesium? I got a question earlier today about magnesium because there's all sorts of really interesting information you can find on social media. I will warn people, be careful about social media and make sure you're getting information from somebody who really knows and maybe has some credentials in equine nutrition before you take everything with a grain of salt. Magnesium, there's information out there saying that horses tend to be deficient in magnesium because forages often are deficient in magnesium. And if they're on a forage-only diet, you might need to supplement magnesium. So when I got that question, I went back and looked at the low values of magnesium because Dairy One has a wonderful forage library. It has thousands of samples of forages, and you can look and see where those fit. So I did some calculations, and even with hays at the lowest magnesium level that I found in Dairy One, it was still enough magnesium for a horse, an 1,100-pound horse that was getting 1% or 2% of its body weight per day in hay with the lowest magnesium was still meeting the magnesium requirement for even up to moderate exercise. And to meet calorie requirements at heavy exercise, they were still getting, with average magnesium in the hay, they were still getting enough to meet their magnesium requirements. So no, I wouldn't say. I don't know how many ration evaluations I've done over my career, and magnesium is just not something I usually worry about. So supplementing magnesium, and especially if you're feeding, a typical hay and a ration balancer, it's not something I'm terribly worried about. Sodium, on the other hand, forages do tend to be low in sodium, and this is why I think just about every nutritionist is going to recommend that one thing your horse is not going to be getting from their forage, and possibly not even from their forage and their feed, is sodium and sodium chloride. So almost every nutritionist is going to say provide salt. Now, I've also seen on social media, there's a big, strong push now that the horses can't get enough sodium chloride from a salt block because their tongues are not rough like ruminants, and so they're not able to lick the salt block. And I have personal experience. Horses are really well able to lick the salt from a salt block. My recommendation is, in general, if you have a plain white salt block available to your horses, they're going to get sodium chloride from it. Now, individual horses are very different. They do not lick the salt block to meet their requirement. They lick the salt block because they like it or they don't. So keep an eye on that. Some horses lick it until it's gone, and they may have an issue called psychogenic salt consumption disorder. And in that case, take the salt block away from them and maybe just add some salt to their feed. But when the horse is sweating heavily, they are losing a tremendous amount of sodium, potassium, and chloride, the electrolytes. And in those situations, you probably want to be adding some actual formulated electrolytes to their feed, or at least adding the salt to their feed. They usually get plenty of potassium from their forages, but that is something when the horse is sweating a lot, either due to work or just temperature, humidity, make sure they are getting adequate electrolytes. Mineral ratios. There's an established calcium-phosphorus ratio. In general, in horses, we want to see about a 2-to-1, 3-to-1 calcium to phosphorus ratio, because these two minerals do interact in the horse's gut. And if there is more phosphorus in the diet than calcium, the phosphorus can inhibit the calcium absorption, and the horse then becomes calcium deficient. We usually do not see the inverted ratios in which phosphorus is higher than calcium in forages. Now, when you're looking at green grass, there's a point in green grass's maturity that it might have more phosphorus than calcium, but that's a short point, and nobody's cutting hay at that point. You can see higher calcium than phosphorus than the 2-3-to-1, but in research, 6-to-1 calcium to phosphorus has been fed to growing horses with no problems as long as phosphorus is adequate. People get excited sometimes with like alfalfa. I've seen 10-to-1 calcium phosphorus ratios in alfalfa, but quite honestly, I'm not that excited about it, because remember where the nutrients are absorbed in the digestive tract? Calcium's absorbed in the small intestine. So in the forages, if the calcium is inside the cell, and so therefore inside the fiber of the cell wall, it may not be available into the hindgut. So quite honestly, I personally, in many years as a nutritionist, I've never seen a calcium phosphorus problem with horses on alfalfa, even when they get these kind of higher ratios. I've heard now that there are people out there saying, oh, beware of beet pulp, because beet pulp has a high calcium phosphorus ratio. My questions there are, okay, first off, did you have your beet pulp analyzed? Because there's going to be variability there, just like every other nutrient. Secondly, how much beet pulp is the horse's diet? Because I sure would not recommend that the horse's entire diet is beet pulp. So if you add some beet pulp as a nice source of fermentable fiber to your horse's diet, the total calcium phosphorus ratio is not going to be that affected. So, and then the other thing, what else are you feeding the horse? Because if you're feeding a ration balancer or a balanced feed, and then you still add some beet pulp, you're still going to be okay. So again, if you're worried about that, get some help from a nutritionist and make sure that you're not terribly out of whack. But I'm way more worried about too much phosphorus than in the ratio. And the reason that comes up is some very popular ingredients, for instance, rice bran and then wheat bran, have much higher phosphorus than calcium. And so if you start relying on like a lot of rice bran for your horse, then you could really whack out the calcium phosphorus ratio. There has been a lot of chatter about copper zinc ratios. And I will tell you, I did my graduate work, some of my graduate work on copper and zinc. And in general, you hear the zinc to copper ratio should be like 3-to-1. And I think that's based on the requirement for zinc is 40 parts per million in the total diet, and the requirement for copper is 10. So if you take 40 to 10, that's say 4-to-1, 3-to-1. So there you go. But does that mean that there is actually a ratio? No, there really is not. We do know that those two minerals interact, but in my research, I think I fed about 600 parts per million zinc and about 15 parts per million copper. So that is about what, a 30, 6 by 15, 40-to-1 zinc to copper, and did not have any problems with the true absorption of copper or zinc. So I will say, don't be too worried about your zinc to copper ratio. Make sure the nutrient requirements are met. You're very rarely going to ever see a situation that you're feeding more copper than zinc. And in my dissertation, I actually said it perhaps would be a problem if your horse was grazing near a zinc smelter. So if you live near a zinc smelter, buy hay from somewhere else. There you go. There are other ratios out there, and I will tell you, they are not based in research in horses. There are some ratios that throw in magnesium, there are ratios that throw in iron, and we don't have research in horses to indicate that those are actual issues. So again, if you got questions, please ask for help. And this is just when I talk about the copper and zinc. These again are real analyses, and you look, zinc and copper are in red, and as I said, the zinc requirement is 40 parts per million in the total diet. Copper is 10. If you look through here, there is one Bermuda grass sample that had 48 parts per million copper. I'm sorry, 48 parts per million zinc and 10 parts per million copper. That was the only hay sample, and these came from all over the US. So again, got to make sure that you feed something to meet the nutrient holes that are present in a forage-only diet. So final thing I look at on an analysis is relative feed value, because that's a really cool thing. And it's just a calculation that combines the digestibility and potential intake of a forage into one number. It's based on ADF and NDF. And this is not an absolute number, it's a relative number, but in general, the higher the relative feed value, the better the hay quality. So here we go. This is an actual analysis. And you look way down at the bottom, there's a relative feed value, 151. What does that mean? Well, I put together this little kind of handy-dandy cheat tool, and relative feed value greater than 151, that is really high quality alfalfa. And that's an alfalfa, it tends to be considered dairy quality alfalfa. It's going to make your easy keeper fat. Might be good for your lactating mares or young growing horses, but it's also really expensive. So that's not hay we tend to see fed to horses. Going down 125 to 151, that's good quality alfalfa, appropriate for performance horses, lactating, gestating mares, growing horses, hard keepers. It's probably not going to be good for your easy keepers. And even there, you need additional vitamin, mineral, and possibly protein sources. And going on down, the thing I want to point out there at the bottom, quality standard of 5, less than 75, that's very poor quality. It's either really horrible alfalfa or just very poor quality grass hay. Now, if that's what you have, I'm not going to say don't feed it. Be aware you might have a higher risk of impaction colics, and you might want to look for something to supplement that hay that's going to give more fermentable fiber and more nutrition. So for some recommendations, horses with high energy and nutrient requirements, utilize high quality hays. Low energy requirements, utilize medium quality hays. Notice I never recommend poor quality hays, because again, an increased very poor digestibility, very poor voluntary intake, and a higher risk of impaction colics. For carb intolerant horses, possibly medium quality hays. Warm season grasses tend to have lower soluble carbs than cool season grasses. If you've got a horse that can deal with the calories, alfalfa is very low in soluble carbs, in starch and sugars. However, if you have a very easy keeper that is sensitive to soluble carbs, alfalfa tends to be higher calorie, so may not be appropriate. So lots of things to take into consideration when you start figuring out with some of these medical situations what kind of hay you need to be looking at. And remember, it's difficult to maintain nutritional consistency in hay if the roughage source is critical, or you don't have good quality roughages or forages available. Then a complete feed that has all the fiber in it to replace the hay in their feed, or just an alternative forage source such as a formulated hay stretcher, or sometimes even just cubed or pelleted forages that come from a company that is consistent in their quality, may be a better choice to maintain consistent nutrient balance. If you are interested in forage analysis, the one I always use is Equine Analytical, which is the horse side of Dairy One, and especially for carbs, because that's kind of the gold standard for WSC and ESC these days, and they do wet chemistry. Some labs are doing NIR for the soluble carbs, which is, I'm not going to say it's bad, but it's not as cut and dried as some of the wet chemistry, because you got to worry about the lab variability and the methods and the standards that they use. So take home message: for horses on hay as a primary forage source, supplementation of specific nutrients is appropriate to support health, performance, and longevity. So amino acids, minerals, vitamins A and E. For horses on green pasture, mineral and possibly amino acid supplementation is appropriate, because if you got a maintenance horse on green pasture, you're still going to need some minerals, but they may be doing fine on amino acids from green grass, because again, green grass is magical. But horses with higher calorie needs can meet those nutrient requirements with a balanced formulated feeds. But easy keepers, I still recommend at least a ration balancing feed or supplement to make sure amino acids, vitamins, and minerals are, because, you know, my goal is for every horse to get to be 37 and a half like Boo and still be sound and healthy and doing lessons and passing his sleep. So on that, thank you very much for your time and attention. And Lori, do we have any questions?
Yeah, we only have a couple of questions. So if anybody does have any questions, there's up in the top, there's a Q&A little bubble at the top. You can put your question in there. So the one is hay preservative as dangerous for the horse? Propionic acid, acetic acid.
That's a really good question. And I'm going to refer back way back at the beginning when we talked about volatile fatty acids. And one of the volatile fatty acids that is produced in the horse's cecum is
propionic acid.
Yeah, propionate. Yeah. So I would say no. What you may have issues with prop acid is palatability. Mm-hmm. And actually, there are a lot of feeds, especially sweet feeds. Prop acid is used as a mold inhibitor, but and especially in the summer when it's hot and humid, you're gonna need mold inhibitor if you want your feed to last for longer than 30 days. But if you bounce back and forth with adding prop acid to not adding prop acid in the winter, when you add prop acid, a bunch of horses are going to go off feed. So a lot of the sweet feeds now have prop acid in them all the time. So that's the big issue really on forages as well. If it's got prop acid, your horse may say, nah, can't eat that. That is different. It is bad.
And so,
But I would say
sometimes,
give them time. They'll probably get used to it.
yeah, sometimes with the very large bales, like the big squares, you can actually smell it.
Yep.
I mean, they're putting so much on. The other question is talking about changing the hay abruptly without gradual replacement. Is there a good way to support my horse's gut during such a change? So I guess what she's referring to is the barn is getting one load, and then the following week or month or whatever, a new load comes in, and it could be completely different.
And that is such a good question, because there actually is research on risk factors of colic. And the number one risk factor of colic is a sudden change in hay. People don't even really think about that. Ideally, when you get a new batch of hay, if it's very different, you throw a flake of the old and a flake of the new and let the gut gradually get accustomed to the difference in the hay. Usually it's not a problem, because people tend to try to, get from the same supplier. But if you've got a horse that you've had colic issues with, if it's a sensitive horse and has had some digestive things, then yes, if you can gradually switch them over, a week or two, by 2 weeks, if you can do it over 2 weeks, that usually gives the gut microbes a chance to adjust their population, because in the hindgut, you have the fiber digesting microbes and you have the starch digesting microbes, and there's kind of a balance of those populations. And it's when you really change the diet so much that those populations then just kind of get all unbalanced and out of whack. That's when you really can see digestive problems in your horse.
Next one is, what type of salt block is recommended? Straight salt or mineral? Are blue cobalt salt licks safe for horses?
I'm going to address the first part there. Plain white salt. The trace mineralized salt blocks actually just have enough trace minerals, and particularly like a little tiny bit of iron, to give it that interesting red color. But if you look at the tag, it's like 98% salt. So you may as well just a plain white salt block. And yeah, I personally, I've heard that question asked before, and I'd have to go digging around to find that answer on the blue cobalt one. But in general, for horses, we just recommend plain old white sodium chloride. And if you want to make your own electrolyte, I have heard it recommended that a mixture of plain white salt, sodium chloride, and then light salt, which is potassium chloride, if you need to get some potassium. But if you're going to that much effort, then I would recommend a formulated electrolyte, which is primarily sodium, potassium, and chloride. And looking at the ingredients, you don't want a lot of dextrose in there. That's a sugar, because that's not what they're sweating out. It's the electrolytes.
I get that one a lot about the salt blocks. I hear that a lot. Next one is,
I have one little caveat there.
Yep.
My one guy, the Palomino Appy that you saw on my first slide, that was my eventer until he's kind of pseudo-retired, he really likes the pink Himalayan salt block, and I love him. So he has a little plain white salt block, and I also get him some pink salt. Yeah.
Well, I'll leave it at that.
Yeah. Not for any nutritional need. It's just because he seems to like it.
And it's a big seller for pink salt. Can you speak to the increased protein requirements of the senior horse?
Yes, I can. The big thing with senior horses, they do tend to have some muscle wasting. And so it's a combination. I don't know really that it's an increased protein requirement, or if it's more that they're getting less out of their forages because their dentition becomes compromised, and they're not as well able to chew the fibrous forages. So at that point, we need to make sure that they are getting protein that is easily digested in the upper gut. And that's why a feed that's designed for the old guys is going to tend to have like 14% crude protein. And that protein is going to often come from soybean meal because that's a source of protein. It's a very high quality, bioavailable, easily digested in the upper gut. So the old guy is getting all the amino acid it needs in the upper gut. And quite honestly, Boo, at the last 5 years of Boo's life, he would still chew on his hay, but we gave him like a flake of hay a day so he could sort through and pick out the few
Soft.
blades that he thought was tasty. But yeah, his feed, he was getting a mixture because I'm a nutritionist and I had to find something that Boo would love the best. But it was a mixture of senior feeds that all the primary protein source in those, it was 14% and it was soybean meal just to make sure, and flaming PPID, and I really did not see a lot of muscle wasting with him because I provided the very high quality protein in adequate amounts for him to make use of.
And I think we're going to discuss soybean in the Mythbusters.
Yeah.
Which might prompt somebody to ask something, but we'll keep going here. Back to the salt block again. My horse almost never licks salt, although she sweats quite a lot during exercise. Tried different types of blocks with no luck. What may be wrong with her? Can there be enough sodium in hay?
It is, if they're sweating a lot, like I said, I did my research. Maybe I didn't. I did graduate research on copper and zinc, and then I did it on electrolytes. And I was in South Central Texas doing this. And my maintenance horses did meet their sodium requirements without additional salt, but they were not doing anything and they were not really sweating. Now, if your horse is not, and Boo did not lick a salt block. There are horses that don't like salt blocks, and if they don't eat it, then they're not going to get it in. So in those situations, there are a couple tricks. You can add either electrolytes or just salt into their feed, and sometimes you have to get creative at finding something that they really like feed-wise that you can get a little bit of electrolyte into them. You can get the paste electrolytes, and so for periods when they are really sweating profusely, you can go ahead and just give it to them with an oral syringe, and that way you know that they're getting it. There are some electrolyte preparations that are still tasty and work well in water, but if you're giving them electrolytes in their water, make sure you give them electrolyte water and then also clean water, because they may not, you don't want to back them off on their water intake. And then finally, if you're really at your wit's end and you know that they need electrolytes, you can hide them in some sort of mash. There are some commercially prepared mashes, or you can make a mash. You can take, tasty senior feeds, or some people just use soaked beet pulp, and find a mash that your horse likes and dissolve the electrolytes in the mash. So sometimes we have to get tricky to persuade our horses to eat what is best for them.
That is true. Okay, next one. What hay is best for horses who vary in age, body condition? It doesn't have a lot of description here, so.
Yeah, that's okay. And I go back to the maturity of the quality of the hay determined by maturity, time of harvest, because you can use the same hay. You can use same good quality hay for all the different types of horses, and then supplement on top of that hay, because it can be tough if you've got easy keepers, you got hard keepers, you got growing horses. I would love to say there's a one size fits all, but there may be a one size fits all for the hay, but then you have to come back and individualize or customize with what you feed in addition to the hay. So for instance, you got easy keepers and you got moderate quality hay, ration balancer. You got growing horses or performance horses, come back with a growth feed or a performance feed. But, again, I would love to say one size fits all, and it doesn't. One thing I should have mentioned about forages too, especially for those easy keepers, because sometimes you're going, okay, and now I'm going to get into gastric ulcers, because you want forage in the horse's gut as much full time as possible to minimize the risk of gastric ulcers or other GI tract issues. But for some easy keepers, if you give them free choice hay 24/7, they're going to be so obese that they are at high risk of metabolic problems. So that's when I'm a big fan of slow intake hay feeders. Now I realize if you got a herd of horses, that can become pretty cumbersome in just managing. But I've got the younger horse I ride has had issues with ulcers, and I went through a round of omeprazole and then said, okay, so now do I need to start figuring out, because there are some supplements that are pretty effective in managing the risk of ulcers. I was going, okay, before I spend all that money, because I'm a horse owner, I would really like to minimize how much. I would like to have enough cash to someday retire. But so I started working with slow intake, hay nets, and I've ended up, this guy now gets his hay. He's out during the day. He's in the stall at night. And by 10 o'clock, he had either eaten all his hay or peed and pooped on it. So it was unusable. So now he has a hay pillow that is stuffed with 4 to 5 bales of hay, and it lasts him all night.
Yeah.
And I have not had to treat him for gastric ulcers. I'm knocking on wood again. So,
and I get a lot of and you probably do too, where you mentioned earlier, you've got a group of horses and they're all eating off this netted slow intake hay, but you've got 1 or 2 or 3 hard keepers that just aren't getting enough hay. And so sometimes it doesn't work for everybody. Do you find
yes.
that? Yeah.
Yeah, and sometimes keeping herds of horses, figuring out can be complex.
Mhm.
So, yeah, but I feel for everybody, because I've been in that situation too, and you just kind of have to do the best. Of course, if you've got an obese easy keeper, the other thing you can do is exercise it. And so the more you exercise them, the more calories they use. I would love to say there is a magic cure for obesity in horses, but if there was, that would mean there was a magic cure for obesity in humans, and I would be, like a size 4. I am not. So exercise, cutting out calories and increasing calorie use with exercise that's the magic.
It is. Okay, next one. Would you feed loose salt with grain? I've heard that it can be absorbed better when it's loose and fed in grain. Any validity to that?
Salt is salt. Yeah, sodium chloride is amazingly easy to be digested and absorbed. So I would, my guy that likes the pink Himalayan salt, who also gets a white salt block, likes his salt. And I ran out, and I always have loose salt too, in case somebody, colics and I want him to drink more. So I gave him a little bowl of loose salt, and it went way too fast. So he just it made it too easy for him to eat. But he likes salt. My other guy who doesn't care for salt, a bowl of loose salt will last him his life. So it really depends on the horse. I would not say that loose salt is more digestible, more absorption. And like I said, I don't buy into the horse's tongue is not adequate. And what I want to say is, because we have tongues that are also not they're pretty smooth. I would say go get one of those white salt blocks and take a big lick of it and see how much salt you get, because I think it's quite a bit.
But you wouldn't say it's better absorbed if it's fed with the grain.
No, actually,
No.
no.
And I do
No.
suggest feeding salt with feed, putting it in the
Yes.
feed if they don't have blocks.
And I would say the thing about putting it with grain that has absolutely nothing to do with digestion and absorption, it's if you have a horse that's at risk of gastric ulcers, then you would want to put the salt in the grain, because gastric ulcers are open wounds in that horse's stomach. And we all know about salt on wounds. So I would
Salt on a
not.
canker. Salt on a
Yeah.
canker is a perfect
Ow,
example.
ow, ow. In that case, I would go ahead, because salt in the feed is not going to cause the pain that just, loose salt or even salt from a block would, when they're just out there licking a block and there's not a lot of feed going on in the stomach. Then yeah, in the feed is going to be better if you know you're dealing with gastric ulcers.
Okay. Next one. How would you manage a diet for a broodmare with ID on the last 90 days of pregnancy and during her lactating phase?
Okay. If you're not aware, ID is insulin dysregulation. So this is a horse at risk. With insulin dysregulation, they're at a higher risk of laminitis. So the concern then is the soluble carbs in the diet. What I would recommend then, and she just said, or she or he just said, insulin dysregulation, did not say obesity, correct?
No.
Okay. Insulin dysregulation not associated with obesity, I would look for, because during the last trimester of pregnancy and then especially early lactation, that mare's calorie requirements just like an early lactation or double that over maintenance. So we got to make sure, and then protein requirements, amino acid requirements are higher, and we just got to make sure we are providing her with the adequate nutrition. But we want to reduce the risk of glucose insulin response leading to laminitis. So what I would do is look for a higher calorie feed that is lower in soluble carbohydrates. And it can be higher calorie, like with fat added, because fat adds a lot of calories but does not contribute to a glucose insulin response. So a good growth feed, high calorie. There's a lot of feeds out there that are high fat and fiber that would be appropriate for these situations. Now, if we have an insulin dysregulated pregnant mare that is also obese, we're talking about a different situation. And some of these mares actually can still get adequate calories from a good quality forage. And in that case, I would ensure that they're getting an adequate ration balancer to get the nutrients. And in those situations, I'm probably going to, if it's a very sensitive horse as far as hay, preferably a warm season grass hay, which is going to be, probably not grown too much in Canada. But there are a lot of avenues now. There are growers that are like teff hay is it's a tropical hay that's going to tend to be lower in soluble carbs. And there are places you can get bagged teff hay. Again, if you're not worried about calories as much, alfalfa is a great hay for insulin dysregulation if you're not as worried about calories for that horse.
Yeah. Okay. Next one is, do you recommend soaking pellets? Have heard of horses choking without soaking first, making into a mash.
Depends on the horse, completely depends on the horse. The choking is usually an issue with horses that bolt their feed, that just suck it down without chewing it properly, or horses with poor dentition that are not able to chew it properly. So the first thing I would look at is what was the cause of the choke in horses. And sometimes if a horse has choked and it was a really severe choke, there may have actually been a laceration in the esophagus. And then when that heals with the scar tissue, it has less elasticity. And so you get a stricture than in the esophagus, and they're more prone to choke. If that is a situation, then yes, soaking the pellets will help, because it's almost, the pellets become a mash and there's less chewing needed to get it down the esophagus. Some other things, there are slow intake feeders that may be helpful. As a horse gets older with a poor dentition, they often need to go to soaked feed, but I keep bringing up Boo. Boo ate pellets until his last day. And I was like, and he managed to chew up his pellets with, his 4 teeth left. So it's something to be aware of with horses. And of course, this is really old school. But one of the first things when I was young, when you had a horse choke, you put big round rocks in the feeder. Then they had to pick around the rocks.
Yeah, that's the one I always suggest.
Yeah, it's old school, but it certainly works for many horses. Not all horses, but for many horses, just slowing them down with the rocks will help.
And now they're even making buckets with the pockets in the bottom, so they have to go in those pockets and get the feed. Okay, thank you. Next one, does chopping hay make a difference, especially for older horses?
Yeah, it's when you have smaller particle size, then it can be easier for them to chew. So yeah, and I've seen on social media that people are using like chippers and things to chop up their hay. So it certainly can help. There may come a time that even chopped hay has too much fiber content, and it's too hard to chew for the old guys, and they just don't get as much nutrition out of it. And that's when they probably need to be going to a pelleted complete feed that has the forage. And there are all sorts of alternatives to provide the fiber. Soy hulls can provide the fiber. The beet pulp can provide the fiber. So there's a lot of different ingredients in a complete feed that can replace the loose stemmed hay in the diet. But yeah, the chopped hay might be a good first go-to before the horse gets to the point where they just can't even handle that.
Yeah. Okay. Next one. For horses on a dry lot for the winter, what is your preferred way of managing hay consumption?
Oh, goodness. I'm in Kansas. We have a lot of round bales.
Yeah.
So, yeah. And there are issues with round bales. If you get a round bale feeder, I mean, the best situation with round bales is if they're stored inside, so they're not sitting outside getting, mold on the exterior. And then it helps too if they're, there are all sorts of interesting contraptions like hay huts that you can get that, you feed with a little hay hut and that has a roof over the round bale and the horses stick their heads in. So those sorts of things can really help with feeding round bales. The trickiest thing with round bales is if you have a horse that has a tendency to equine asthma, when they're eating round bales, they stick their head, asthma is triggered by respirable antigens, and they're going to breathe in all this stuff from the hay in a round bale. So in those situations, a horse that's having any kind of asthma problems really shouldn't be on a round bale. But like I said, we feed a lot of round bales at the barn where my horses live. And I am lucky enough that I haven't dealt myself with a horse with asthma, but if you do, then you don't want a round bale. But if you do, so I would say in a dry lot, if you're feeding square bales, some sort of feeder is preferable. I am a fan of having the hay chest height or lower, because when the hay is up, they're breathing in all the dust from the hay. I've got clients that have slow intake hay nets hanging around the fence
Yeah.
of their dry lot.
Yeah.
So there are a lot of options there, but
So this
hopefully that
next,
helped.
I hope so. The next one is at this time of year, I get more and more questions about this, and this is a customer of ours. Way to combat fecal water syndrome in older and bringing stomach flora back to normal. But the fecal water syndrome is a big thing with these older horses.
Yes, and it is tricky, and that could be its own presentation. But one of the successful, oftentimes, protocol has been to take these horses off long stem forage entirely and put them on a complete feed, with the thought of basically reducing the mechanical scratch factor, because you're probably dealing with some sort of chronic inflammatory condition of the hindgut. So
Okay.
reduce the scratch factor in the hindgut for a period of time, and let that condition resolve, and then very gradually start bringing back in preferably green grass to start with, and then high quality hay, and to see if you can get the basically kind of the gut reset to the point where it can handle long stemmed hay again. I will make a comment about a Kentucky Equine Research product that is fairly new, that might have, if it's available, it's not available everywhere at this point, but we're working on it, getting it available everywhere, and it's called Resolve and EQ, which is, it's got a very unique fatty acid profile. Everybody's kind of aware of omega-3s now as mediators of inflammation, and this oil has a considerable amount of omega-3s, and it's the DHA and EPA that are more bioactive than the ALAs that you get from the typical plant sources. But it also has a kind of a more novel plant oil that has a high omega-6 content, but it's a very specific long chain omega-6 fatty acid that is also very helpful in these chronic inflammatory conditions. And so that, we haven't done research at this point. We've done research with gastric ulcers, but we've not specifically done research with hindgut conditions. But I have heard some really good responses of specifically recommending the Resolve and EQ for fecal water syndrome and chronic diarrhea. And I think it's just that having those omega fatty acids that are helpful with, again, chronic inflammatory conditions, that may be something that we will be talking more about in the future. But that's the first thing I would do is look at the forage sources and try to, transition my horse and see if getting them off the long stem forage
Makes a
will
difference.
help with that. Yeah.
Okay. Then you're looking at forage pellets. You're suggesting to go off even hay cubes.
Yes.
You're trying to get that scratch factor.
Yep.
Okay.
Yep.
Okay. That is it for the questions. We've had a couple people. Thank you very much. It was very instructive. Thank you for sharing your knowledge. Much appreciated. So I think
Well,
we're coming to a
thank you to
close.
everybody for participating. We really appreciate that as well.
Yeah, I think we had some people struggling to get on. So I did have a couple of emails. So I think some people were not able to get on. So we will be, this is recorded, so we will have it available for anybody that wasn't able to get on, but anybody that's on right now is on. Thank you everyone for attending. If you have any questions after the webinar, you can always contact me. I like that. That's cute.
It's very nice.
And we'll be sending out information on the upcoming upcoming topics. So I think the next one is a month from now, and it will be on, we're doing metabolic next, aren't we? Metabolic conditions.
I think so.
Yes.
I'd have to look at my notes.
Yeah. Well, thank you, Dr. Young.
Very
And
welcome.
thank you, everybody, for attending. And we'll say good night.